Academy. In this video, we are going to discuss about radius of convergence of a power series. Suppose summation an z power n is a given power series, then its radius of convergence is given by limit n tends to infinity an by an plus 1 or limit n tends to infinity 1 by modulus an power 1 by n. So both the formulas we can use. Depending on the nature of the series given, we can make use of the formula. Okay, what do you mean by radius of convergence? See, when you are given with a power series, it will be an infinite series, isn't it? That series will converge within a circle only. Okay, the radius of that circle is called radius of convergence, and that circle is called circle of convergence. So what about outside the circle? Outside the circle, the series will become divergent. Okay, so any power series will be convergent only within a circle. That circle is called circle of convergence, and its radius is called what? Radius of convergence. Right, now let's see some problems. Find the radius of convergence for the following series. The first one is summation 1 by n power n z power n. Here the coefficient of z power n is taken to be an. So an equal to 1 by n power n. Okay, we have two formulas. No, you can make use of any one of them. Look at the problem. Here power n we are having. No, so for this I can make use of this formula. So find an power 1 by n. So an power 1 by n means what? This power n will get cancelled. So simply 1 by n. So let me substitute in the formula. R equal to limit n tends to infinity 1 by modulus an power 1 by n. So limit n tends to infinity. N, this is n only, no? So no need to take the modulus. Simply let me write 1 by n. So 1 by 1 by n will be what? Simply n. So as n tends to infinity, this value will become infinity. That means the radius of convergence is infinity. That means the given series is convergent for all values of z. That is, whatever may be the value of z, this series will be convergent. Okay, then next problem, summation z power n by n factorial. So here coefficient of z power n is 1 by n factorial. This is taken to be an. So since there is no powers of n, I am going to make use of this formula an by an plus 1. So for that I have to write what is n plus 1th term. So if nth term is 1 by n factorial, n plus 1th term will be what? 1 by n plus 1 factorial. Okay, right. Then r equal to limit n tends to infinity an by modulus of an by an plus 1. Right. So 1 by n factorial by 1 by n plus 1 factorial. Okay, right. Since all the values are n and n plus 1, no need to take that modulus. We can simply write like this, n plus 1 factorial by n factorial. Okay, now this n plus 1 factorial can be written as n plus 1 into n factorial. So this n factorial get cancelled. Simply what we have? Limit n tends to infinity n plus 1. Okay, so as n tends to infinity, this value will become infinity. Therefore, this series is also convergent for all values of z. Right? Then next problem, summation 4 plus 3i power n z power n. So here the coefficient of z power n is 4 plus 3i the whole power n, that is taken to be an. Since it is containing power n, I am going to make use of this formula. Right? So an power 1 by n will be simply 4 plus 3i. So what is the formula? R equal to limit n tends to infinity 1 by modulus an power 1 by n. So limit n tends to infinity 1 by modulus 4 plus 3i. Here this is a complex number, no? So this modulus you have to use. So modulus 4 plus 3i is what? Square root of 16. 4 square plus 3 square. So 16 plus 9. So it is, square root of 25. Square root of 25. So it will be what? 1 by 5. So the radius of convergence is 1 by 5. That means the given series converges only within the circle modulus z less than 1 by 5. Outside the circle, the series will be divergent. Okay. Then next problem, summation 1 plus 1 by n the whole power n square z power n. So here an is 1 plus 1 by n the whole power n square. An power 1 by n is 1 plus 1 by n the whole power n. Okay, since power is n square, I am making use of this formula. So r equal to limit n tends to infinity 1 by modulus an power 1 by n. Since only n terms are there, no need to take the modulus. Simply write it as 1 plus 1 by n the whole power n. But what is the limit of this value? E. Right? So r equal to 1 by e. Therefore, the given series is convergent when r is equal to 1 by e. Then, last problem. Summation n plus 1 by n plus 2 into n plus 3 z power n. So what is an? N plus 1 by n plus 2 into n plus 3. What is an plus 1? Replace all n by n plus 1. So it will be n plus 2 by n plus 3 into n plus 4. Now an by an plus 1 will become n plus 1 by n plus 2 n plus 3 into n plus 3 plus n plus 4 by n plus 2. So n plus 3 get cancelled. So what we have? N plus 1 into n plus 4 by n plus 2 the whole square. Now the radius of convergence r equal to limit n tends to infinity modulus an by an plus 1. So equal to limit n tends to infinity. Since we have all only n terms, I am omitting the modulus n plus 1 into n plus 4 by n plus 2 the whole square. Now you take n outside this, and from this also you take n outside. So it will be n into n what? N square into 1 plus 1 by n, 1 plus 4 by n. Here also you take n outside, so it will be n square into 1 plus 2 by n the whole square. So that this n square get cancelled, we will be having this term alone. When you substitute n tends to infinity, it will be 1 plus 0 into 1 plus 4 by 0. So in the numerator will be simply what? 1. Similarly, the denominator will also be equal to 1 because it will be 1 plus 2 by infinity is what? 0. So 1 by 1, it's simply what? 1. So the radius of convergence is 1. Okay, that's all. Thank you.